Assalamualaikum. Today we would like to present for assignment thermodynamic. The topic that we choose is refrigeration, vapor compression cycle basic and refrigeration, vapor absorption cycle improve. This is our group member. Firstly, it's me, NURULHUSNA binti Muhammad AZHAR, ABDUL HAIKAL bin RASHID, and lastly MOHAMAD IZZAT NAJMI bin MANSOR. I will explain for introduction part. Vapor compression refrigeration systems are commonly used in industrial facilities to create environments conducive to the preservation and safe storage of products. In this guide, we will go over how a compression refrigeration system works and the four main components used to create the refrigeration cycle. The vapor absorption refrigeration system include all processes in vapor compression refrigeration system such as compression, condensation, expansion and evaporation. The refrigerant used in vapor absorption system as ammonia, water or lithium bromide. The history of vapor compression goes back to 1805 where Oliver Evans, an American inventor, described a closed vapor compression refrigeration cycle for producing ice. The first working vapor compression refrigeration system was built in 1834 by another American who was living in the UK. It's Jacob Jenkins. In the early years of the 20th century, the vapor absorption cycle using water ammonia system was popular and widely used, but after the development of the vapor compression cycle, it lost much of its importance because of its low coefficient of performance, about the 1/5 of that of the vapor compression cycle. Next, for application, vapor compression cycle are an efficient method of moving energy around. They are utilized in the majority of refrigerators, freezers and air conditioning systems produced today. They also have practical application as heat pumps, a term describing an electrically power to heat an enclosed space such as your home by transferring heat energy from outside to the inside. The vapor absorption refrigeration system are best for location where heat energy is readily available at a low cost. This process is best for steam power plants. Steam power plants can easily run this refrigeration system using the waste heat produced in the power plant. Lastly, components for refrigeration vapor compression cycle basic is compressor, condenser, expansion valve or throttle valve, and lastly evaporator. For refrigeration vapor absorption cycle improve is evaporator, absorbers, pump, generator, analyzer, pressure reducing valve, condenser, and lastly expansion.
Assalamualaikum warahmatullahi wabarakatuh. My name is AZZIM HAIKAL bin RASHID. My matrix number is B0920102882. Today I'm going to talk about the working principles of basic and improved cycle of refrigerator. So the principle of basic and improved cycle is a gas or a liquid change its temperature when forced through a capillary tube or an expansion valve, separately kept in an insulated system where no external heat transfer occurs. Next, refrigeration cycle. So the cycle diagram of basic and improved cycle is also same. First, the compressor. From the compressor, we get high pressure and high temperature. Next, condenser. At condenser, high pressure and low temperature. Then he goes to the receiver or storage device. After that, they goes to the restrictor. At restrictor, there is low pressure and low temperature. After that, liquid refrigerant in to the evaporator. At the evaporator, the vapor refrigerant out. Then he goes to the accumulator. At After that, the low pressure, and it's got low temperature. Next, they are cycled again to the compressor. And that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad IZZAT NAJMI bin MANSOR. My matrix number is B0920100065. I'm from 2BMMV S2/1. So today I'm going to talk about disadvantages of basic cycle and advantages of improved cycle, and also the suggestion to further improve the cycle. So disadvantages of basic cycle. Firstly, it's required oily methods. Secondly, HCFC refrigerants resulted in depletion of ozone layer. Thirdly, it needs to service occasionally. Fourth, a very costly system. And five, easy to leak. Advantages of improved cycle. It has only pump motor as a moving part. It operates soundly and low maintenance costs. It can still operate using all the thermal energy as input. It can be used in large working capacities, and it is cheap and easily available. Suggestion to further improve the cycle. Optimize setting. To guarantee optimal performance, several various settings and parts can be examined. Compressor size. We have to choose the right compressor size to maintain the efficiency. Install VFDs on screen compressor. Screw compressors with variable frequency drives will have their mechanical efficiency increase. Install VFDs on condenser motors. When VFDs are used on condenser motors, head pressure is stabilized and heavy repetitions and violent start or stop cycles are avoided. Use floating head pressure to maintain ideal temperatures. The appropriate temperature for compressor and condenser operations may be maintained using floating head pressure. And lastly, use a completely integrated automation system. An automated system can do computations and modifications on its own, whereas a manual system requires ongoing operator attention, is prone to human mistake, and responds more slowly. That's all from me. Thank you.